What if I told you there's something out there so unimaginably large that a beam of light, traveling at 186,000 miles per second, would need 10 billion years just to cross it? That's not a typo. 10 billion years. For context, the universe itself is only 13.8 billion years old. This thing is so massive it technically shouldn't even exist according to our best models of how the cosmos works. And the wildest part? A teenager on the internet gave it its name. Stay with me, because this one is going to break your brain. It's called the Hercules-Corona Borealis Great Wall, and it is the largest known structure in the entire observable universe. We're talking about a colossal web of galaxy groups and galaxy clusters strung together in what astronomers call a galaxy filament, stretching roughly 10 billion light-years across. Some recent studies from 2025 suggest it might actually be closer to 15 billion light-years, which would make it even more absurd. Let me try to put that scale into perspective for you. Light from our sun takes about 8 minutes and 20 seconds to reach Earth. Give that same beam of light 2.5 million years to travel, and it would barely reach our nearest major neighbor, the Andromeda Galaxy. Our entire Milky Way is about 100,000 light-years across, and even the Laniakea Supercluster, this enormous collection of 100,000 galaxies that includes our own, spans about 500 million light-years. The Hercules-Corona Borealis Great Wall is roughly 94,000 times wider than the Milky Way. It makes superclusters look small. It dwarfs every other known cosmic structure by a ridiculous margin. So how did we find something this enormous? We didn't exactly photograph it. In 2013, a team of astronomers led by Istvan Horvath, John Hakila, and Jolt Bagoli were analyzing data from NASA's Swift gamma-ray burst mission. Gamma-ray bursts are the most powerful explosions in the universe, released during catastrophic events like supernovae and neutron star collisions. Because these explosions require enormous amounts of mass and energy, mapping where they cluster across the sky gives us a pretty reliable picture of where matter is concentrated. The team noticed something strange, an unusually dense cluster of gamma-ray bursts all sitting at similar distances, roughly 10 billion light-years away, concentrated in the direction of the constellations Hercules and Corona Borealis. That concentration of bursts pointed to a massive underlying structure. And here's where the name gets fun. The term Hercules-Corona Borealis Great Wall wasn't coined by a professor or a space agency. It was added to Wikipedia by a Filipino teenager named Jondrick Valdez after he read about the discovery, and even the original researchers eventually adopted it. The name is a bit misleading, though, since the structure extends well beyond those two constellations into Lyra, Boötes, and Draco. It's also more roundish than a typical flat wall, making supercluster a more accurate label. Now here's where things get controversial. Not every astronomer is convinced this thing is real. The cosmological principle, which is a foundation of modern cosmology, says that at large enough scales, matter in the universe should be spread out pretty evenly. Structures bigger than about 1.2 billion light-years aren't supposed to form under standard models. The Hercules-Corona Borealis Great Wall is nearly 10 times that limit. A 2020 paper argued the gamma-ray burst clustering could be a statistical artifact. But also in 2020, the original discovery team published a reanalysis supporting its existence, and a 2025 study using 542 gamma-ray bursts with updated data further strengthened the case, even suggesting the structure is 50% larger than originally thought. The proposed Theseus satellite mission could eventually settle the debate by detecting thousands of additional gamma-ray bursts and mapping the sky with much greater precision. Whether the Hercules-Corona Borealis Great Wall is confirmed at its full staggering scale or turns out to be something we've misread in the data, the fact that we're even having this debate is incredible. If you want to keep exploring the biggest, strangest, and most mind-bending objects in the cosmos, hit subscribe and drop a comment telling me what cosmic mystery you want us to tackle next.